Okay, so I'm going to today look at the DEB mock paper from 2020, and I'm going to do question 4, which is the surface development question. So it says the elevation and view of a portion of a slide tunnel are shown. The slide tunnel consists of a truncated cone A and a truncated cylinder B as shown. The 3D graphic of the completed side tunnel is also shown. Part A, draw the given elevation and in view. Part B, draw the development of the conical surface A. And part C, draw the development of the cylindrical surface B. So what I'm going to do is I'm going to start by drawing the elevation and the in view. And then I'm going to pay particular attention to how to get this inside circle here on the in view before we start into the developments. So once you have this much of the elevation and in view done, the hardest part with this is being able to draw this inside circular shape in the in view, and that all comes from this truncated cone that we have here in elevation. So it's truncated here along this 60-degree line. So what we need to do now is we need to be able to show that in our in view. Now in the question it looks like a circle, but it's actually not a perfect size circle. Okay, so what we're going to have to do is we're going to have to split up our cone here in our in view. So there's the base of the cone, split that up, bring it to the base of the cone in the elevation, join it up to the apex, and then where it crosses this truncated line in our elevation, then we're going to bring them points then back to our in view, and we're going to find them then on each corresponding element to the base of our cone. So what you need to do then is identify these points where it crosses each line, and we need to bring them back and show them points then in our end view. Now to get the middle one, this middle point here, this is very important. What you need to do is you need to bring that middle point out, touch the extreme edge of your cone. Bring it down and then rotate it back into position. So in your in view then, mark that off there, mark that off there. Okay, so that's the first part of the question completed. So you have your elevation and you have your in view. So part B says draw the development of the conical surface A. So this is our conical surface A here. So what you need to remember is when you're doing developments, you have to open the line on the shortest seam. Okay, so the shortest seam line that we have is there. That's the shortest part that joins up our cone. So the first thing I'm going to do is I'm going to label my points in my cone like a clock. So we can see now that the shortest seam line lies along the element from point 6. So we're going to open up our development on point 6. Okay. Now the length that we're going to use in our compass is the length from the apex here, which I'm going to call O, down here to the point at the base. That's going to be the length that we're going to use. I'm just going to highlight that. That's actually true length. What I'm going to do now is I'm going to take that length of my compass. Now there's multiple ways of doing this. The way that I like doing it is just drawing it out to the side. So pick a point, draw your arc, and because we're opening it in on number 6, I'm going to just start with number 6 here, and now we need to mark off the length of our development. So it's a full cone, so we're going to have 12 equal sections, and the length that I'm going to take is from a set of numbers, so from 5 to 6. Now the next thing I'm doing is join all these to the point O, the apex. Now that would be the development for a full cone, but we have a truncated cone. So what we need to do now is show that truncation in our surface development. Now in order to do that, what we're going to have to do is we're going to have to use these points that we already used to draw our in view of the truncation, but we're going to have to use these points now to get our surface development. Now the key thing is here, you can't directly take the length from O to each point. You have to bring it out to the true length line, which is the extreme generator of our cone. So you have to project out your length to the extreme generator, and then we can take our lengths then from our extreme generator. So the very first length from there to that first point is for 12. And then that's going to go from O onto point 12. So that's the surface development of the conical truncated cone A. So last part of the question, part C, is draw the development of the cylindrical surface B. Okay. Now with the cylindrical surface B, it's a truncated cylinder. So what we need to do now is we need to be able to show that truncation. So the first thing that I would do is we need to draw what that looks like as if we were looking down here, because we need to be able to draw the surface development of it, so we need to be able to measure its circumference. So we have to draw the diameter of that circle. So if you get the angle of B, project out the center line and the ends. And then anywhere out here, then draw a line for the center line of your circle. On top of it. Now what we're going to do is we're going to divide up that using our protractor into our different 30 degrees. What I'm going to do now is, again, I'm going to number this like a clock, and I'm going to put just 12 here in the middle. 1, 2, 3. Okay. And then what I'm going to do is I'm going to project these points then back to my elevation. So because now it's a surface development, we need to mark off the length of our surface development. I'm going to draw a center line. Because it's truncated at both sides, I'm going to work from a center line in the middle. So I'm going to draw a center line. I'm going to get my length from between 2 points and mark that off 12 times in that line. Okay, and label the points. Now, again, it's important when you're doing a surface development that you open it on the shortest seam line. And again, our shortest seam line for the cylindrical development is on number 3. So it's that line right there. So when I'm doing my development now, I'm going to open it on number 3. Okay, and I'm also going to put in a center line up here. So that was 54 millimeters long. So if I go 27, which is halfway, here's 27. Get the angle of the side and then go perpendicular. So that there is the center. I'm going to do that in a different color. Okay. So to finish our development then, what we're going to do is we're going to take each distance and we're going to mark that off to draw our surface development. So the first distance I'm going to take is the very outside one, number 9. And that distance from there to there should be the exact same. Go to your center line number 9, mark that above, below the line. The next one is 8, 10. The next one then is 7, 11. So above the line, there's 12. Okay, and that there then is the surface development of the truncated cylindrical surface B.